Hey Math 7, welcome to your Unit 4 review, where today I'm going to be going over a bunch of problems that are ones that you've seen throughout the unit and ones that you could also see on your test, mainly focusing on proportional relationships and percentages. So without further ado, let's get going here. Number 1 says the side lengths of the state flag of Colorado are in the ratio 2 to 3. If a flag is 12 feet long, then what is its height? Okay, so first off, again, when we're talking about rectangles, height and length are kind of interchangeable, but I'm just going to call this one my height, and I'm going to call this one my length. And I know that they're in the ratio of 2 to 3. And so one thing that you'll probably hear me say a lot this unit, and that's very helpful, is to make a t-table. And I know that that ratio is 2 to 3. Okay, so for every 2 units, my height, my length is 3 units. And it tells me that the flag is 12 feet long. So under the length, I'm going to put 12. And then I'm looking for this height. Okay, easiest way to go about doing that for me is to say, okay, to go from 3 to 12, I got 4 times bigger. So then if I take 2 times 4, I'll find that missing height, which looks to be 8 feet. Number 2 says Claire mixes 2.5 cups of water with a 1/3 cup of orange juice concentrate. So if you've ever bought like the frozen orange juice at the store before, and then mix it with water, that's what this example is. And then Han mixes 1 2/3 cup of water with a 1/4 cup of orange juice concentrate. Whose orange juice mixture tastes stronger? And explain or show your reasoning. Okay, so I'm going to say Claire, talk about her mixture over here, and Han's mixture over here. And I'm going to be comparing the amount of water with the orange juice concentrate. So I'm just going to abbreviate H2O for water with my orange juice concentrate. Again, I'm just kind of abbreviating to shorten things up. And I know that ratio is 2.5 cups water, so I'm just going to put it in decimal form, 2.5. The orange juice concentrate is a 1/3. Okay, and over here for Han, I'm going to do something similar. So I'm going to compare my water with my orange juice concentrate, and that ratio is 1 2/3 to 1/4. And what we need to be able to do is we need to be able to compare these, and right now I have different amounts of water and I have different amounts of orange juice concentrate. So to me, what looks like one of the easiest things to do would be to try and get my orange juice concentrate to 1 cup. It looks like I'm going to be able to do that easily. And then I'll see, okay, if I use 1 cup of orange juice concentrate, how much water do I use for that? And then I'll be able to compare them a little bit easier. So for Claire, to go from 1/3 to 1, I am tripling my batch. So I need to multiply by 3 over here. 2.5 plus 2.5 would give me 5, plus another 2.5 would give me 7.5. So I'd use 7.5 cups of water to 1 cup of orange juice concentrate in Claire's mixture. And in Han's, I'm starting with a 1/4 cup of concentrate, so I need to make that 4 times bigger to get to 1. So over here, I'd also need to make that 4 times bigger. Okay. So to multiply that, I'm going to make 1 2/3 into a mixed. I'm going to make that mixed number into an improper fraction. So 1 times 3 is 3, plus 2 is 5. So that's the same thing as 5/3. And I'm multiplying that by 4, which is 4 over 1. When I do that, 5 times 4 gives me 20. Over 3 times 1 is 3. 20 divided by 3, well, 3 goes into 20 6 whole times, which would be 18. And there's 2 left over to get to 20. So 2/3 is my fraction. Okay, so now I can compare these a lot easier. when I use 1 cup of concentrate, Han uses 6 2/3 cup water, whereas Claire uses 7.5 cups of water. So in other words, Claire's is going to be a little bit more watered down or taste a little bit more watery, and Han's has less water per 1 cup of orange juice concentrate. So the question says, whose orange juice mixture tastes stronger? Well, definitely Han's. His is less watery. Okay. Moving on to number 3. It costs $3.45 to buy 3/4 pounds of chopped walnuts. Kind of expensive. How much would it cost to purchase 7.5 pounds of walnuts? Okay, and then explain or show your reasoning. Okay, I'm going to use a mental math trick here that is going to make this a lot easier, but again, I'm comparing two things. In this problem, I'm comparing the cost to the pounds of chopped walnuts. So I'm going to just abbreviate pounds as LB. And I know it's $3.45 for 3/4 of a pound. And it wants to know how much would it cost for 7.5 pounds. So 7.5 pounds. Well, one thing I want you to notice is that 3/4 of a pound, if I wrote 3/4 as a decimal, it would be 0.75. And if you look closely, to go from 0.75 to 7.5, we just need to move our decimal 1 to the right. And when I'm doing that, that's essentially the same thing as getting 10 times as big. So on this side, multiply by 10. In other words, move my decimal 1 to the right. Gives me a price of $34.50. Okay. And again, this multiplying by 10, moving your decimal 1 to the right, is a good little mental math trick to remember. Moving on to number 4. It says Tyler ate X fruit snacks and Han ate 3/4 less than that. Write an equation to represent the relationship between the number Tyler ate, X, and the number Han ate, Y. Okay, so if you remember back a couple of units, we talked about the constant of proportionality and writing equations in this form, y equals k times x, where k was our constant of proportionality. So essentially here, you're just looking for a number to put here that represents that constant. And we know Han is y, and we know Tyler is x. Okay? So if Tyler ate x, and Han ate 3/4 less than that, how could we represent that in an equation? Okay, well, I always like to start with my, like we did in our old equation, y equals, so the number that Han ate is 3/4 less than Tyler. So we could represent 3/4 less as 1/4 of what he ate. Okay? It's going to look like that. In our notes, in our examples, we use tape diagrams when we talked about this. I would guess this is around section like 5. That's just my guess, but if I were you, I might go back to that section and just briefly glance over that so you have an idea of how we did that using tape diagrams. Part 2 is very similar to this. It says May skated X miles and Claire skated 3/5 further than that. Okay, so in one way, shape, or form, we're going to have to take this 3/5 and it's more than this original. Okay, so if our original was X miles and then we skated 3/5 more than that, what is 1 plus 3/5? Well, that would be 1 3/5, or you could say 1.6, right? 3/5 is the same thing as 6/10. or maybe you said something like 8/5 if you left it as a improper fraction. So again, y equals our constant of proportionality times x. Okay, how would I figure out how far Claire went? Well, Claire definitely went further than May, so if we take May's and we multiply it by that 8/5 value, we'll find that distance. Or, like I said before, you could replace this 8/5 with any one of these, 1 3/5 or 1.6. Those will all work. Okay. Again, maybe you want to go back to section 5 or 6 and look and see how we use tape diagrams discussing that. Kind of similar here for number 5, where it says Kieran read for X minutes and Andre read for 5/8 more than that. Write an equation that relates the number of minutes Kieran read Y with the number of minutes that Andre read, and use decimals in your equation. Okay? Well, Y equals a number times X, and we know that it's 5/8 more than this. So if I were to put it in fraction form, it would be 1 5/8. This whole that Kieran read plus this 5/8 more than that. Now it does want decimals in our equation, so you just have to take 5 and divide it by 8, and 8 goes into 5 0 times, so I need a decimal and an imaginary 0. 8 goes into 56 times. 6 times 8 is 48. Subtract, I get 2. Bring down another imaginary 0. 8 goes into 20 twice, which is 16. Subtract, I get 4, another imaginary 0. And 8 goes into 45 times. So 5/8 is the same thing as 0.625, but don't forget about your whole as well. So we'd have 1.625 times, oops, that shouldn't be a K, that should be an X. Okay. So again, kind of some refreshers on those types of problems. Please go back and look at the tape diagrams that we talked about for those. That'll help you. Number 6 says the number of fish in a lake decreased by 25% last year, between last year and this year. Last year there were 60 fish in the lake. What is the population this year? If you get stuck, consider drawing a diagram. Okay, so I might just start off with that right away. My tape diagram can be really helpful. I know that last year I had 60 fish, so the total would be at 60. And again, 60 represents all of it, or 100%. And it decreased by 25%. Okay, well, I know 25% is the same as a fourth, so that means I'm going to break this down into 4 groups, and each chunk here will be worth 25%. Okay, so if I broke 60 down into 4 chunks, well, if I broke it down into 2 chunks, I know it would be 30 and 30. Well, what's half of 30? That's 15. So 15, 15, 15, and 15, right? And it says it decreased by 25%. So that means I have to take one of these quarters away. It decreased by 15 fish. Okay, and the question is, what's the population this year? Okay, so if it was at 60 and it decreased by 15 fish, this year's population is 45 fish left. Okay, moving on to number 7. It says a company claims that their new bottle holds 25% more laundry soap. If their original container held 53 fluid ounces of soap, how much does the new container hold? All right, so essentially 25% more laundry soap. We're looking first to find that increase. So I'm looking for, well, what is 25% of 53? Okay, remember, if I were to punch this in my calculator, a couple reminders, 25% to change to a decimal, move it 2 spots to the left. Of in math means multiply. So when I take 0.25 and I multiply that by 53, I end up with 13.25. And again, that means that 25% more is 13.25 ounces. This represents how much more is going to be added. So to find my total, then, I have to take that more amount and add it to my original amount. So 53 plus 13.25, and that's going to give me a total of 66.25 fluid ounces. Very common way to do that. The other way that you could do that is you could say, well, if it's 25% more, that's the same thing of thinking about it as that's 125% of 53. And so maybe you did that. Maybe you said 1.25 times 53, and that would actually give you the same answer as what we got right here. Okay, a couple different ways to tackle that one. Number 8, Tyler's mom purchased a savings bond for Tyler. The value of the savings bond increases by 4% each year. After 1 year after it was purchased, the value was $156. Okay, so it's increasing 4% each year. And 1 year after it was purchased, we had 156. This says find the value of the bond when she purchased it. So before, when she put money into it, how much did she buy? Okay, so I'm kind of tricky on this one because we're kind of working backwards because we don't know what it started at. We're looking for the value for when it was purchased. Okay, so this 4% is going to be important because when we started it, we bought 100% of it, and it increased 4% this last year. Okay, so now this year I technically have 104% because of that increase. Okay, so to find my original now, to work backwards, I could say, well, 104% times the value, I'm going to write in here, the value that I purchased it at. And we don't know this, so that's why we're calling it X. If I took 104% and I multiplied it by that value that I purchased at, it would equal what it's at now, $156. Okay, so if I were to rewrite this so that this is a decimal, I'd say 1.04 times whatever that price was that I multiplied it at, and again, this represents the 104% that it's at now, equals that total of 156. Okay, so to solve for x here, it's just a one-step equation. X is being multiplied by 1.04, so I would divide by 1.04 on each side. That's going to cancel. And 156 divided by 1.04 leaves me with a total of $150 when it was purchased. Okay. Now, if you wanted to work backwards to double check that, you could. You could take 150 and multiply that by 0.04, which is that 4%, and it would give you that $6, which it raised from 150 to 156. Not a bad idea to check using that method sometimes. Number 9 asks you a bunch of percentage questions. It says find each percent of 75 and explain your reasoning. 10% of 75, again guys, remember 10% is like dividing by 10. In other words, moving your decimal 1 to the left. So 1 to the left of 75 would be 7.5. Good mental math reminder. I would know that. I would know that mental math reminder for moving your decimal 1 to the left for finding 10% or dividing by 10. Same thing for 1%, except now instead of moving it 1 spot to the left, we're going to move it 2 spots to the left. Okay, so 1, 2 would give us 0.75. And then for 0.1%, you got it, we're just going to move it 3 spots to the left. Okay, so 0.075. Okay, Now for the last one, it says what is a 0.5%? Sorry, I kind of got cut off there, but it asked for 0.5% of 75. Well, if I know 1% is 0.75, 0.5% is just half of 0.75. Okay, and half of that would give me 0.375. Okay. On to number 10, where it talks about a dinner and a meal. Costs $22, and we got some sales tax. And then the first question asks, how much would it be on a $66 meal? Okay, well, the first thing then I need to know is what's my sales tax percent? That's kind of what I got to figure out. Well, remember, to find that, to find a percent, it's just a part divided by a whole. Well, our part of our sales tax we paid was $1.87 divided by our whole. Well, our total was 22. If you take 1.87 divided by 22, punch it into your calculator, you should come up with 0.085, which, if we make that into a percent, 2 spots, means that we have an 8.5% sales tax, okay, at this restaurant, which is kind of expensive, but different restaurants might have different sales tax percentages. So the question asks, how much would it be on a $66 meal? Okay, well, now if my total is $66, I'm going to multiply that by 0.085 because that's my sales tax. It would cost me $5.61 for tax on a $66 meal. Okay, again, that's fine if you use your calculators for this. And number 2, we kind of already answered. What's the tax rate for meals in this city? Well, that's just the 8.5%. We kind of had to do that first to find this one. We kind of had to work backwards here. Moving on to number 11, another 2-part question. Talks about a bike store that marks up the wholesale cost by 30%. So, we have a manufacturer that makes bikes, and then they send them to the store, and the store marks them up so that they can make some money too by 30%. It says Andre wants to buy a bike that has a price tag of $125. So what's the wholesale? So the wholesale, again, should be cheaper than $125 because this is after they marked it up 30%. So kind of very similar to that problem where we talked about before is you are actually paying 100% is what the wholesale would be, plus they charge it 30% up. So you're actually paying for 130% of this bike. Okay? If we take that and we multiply it by our wholesale, we will find, we're looking for that wholesale price. When we multiply the 130 by that price, then we come up with what the price tag says is $125. Okay, so again, it's the same as working backwards as that problem we talked about before. Okay, so 130% price you pay times the wholesale will give us the price tag. Okay, so working backwards, if I divide by 130%, which is 1.3 on each side, I will come up with a total of $96.15 for that wholesale price. Number 2 says, if the bike is discounted by 20%, how much will Andre pay before tax? Okay, well, the way I like to think about this is if it's discounted by 20%, I'm paying 80%. So I would take 0.8 or 0.80, same thing, and I'd multiply it by price tag to come up with my total. When I do that, 80% of 125 is $100. And again, this is before tax. We don't have to worry about tax. All right. Moving on. We're winding down here, getting close to the end. Number 12 says, with a coupon, you can get a pair of shoes that normally costs $84 for only $72. What percent was the discount? Okay, so the first thing that I'm thinking about to find the percent of discount is I need to actually find the discount. So if originally they were $84, oops, sorry, my screen jumped here. I must have hit the wrong button. If originally they were 84 and we can get them for 72, I'm getting a $12 discount, right? $12 discount. And I just found that by subtracting that amount. The question asks, what percentage was the discount? So what I need to do is take my discount then, and I need to divide it by the normal cost of my shoes. So when I take 12 and I divide it by 84, punch that into my calculator, I come up with 0.1428. And to make that a percentage, again, I'm going to move it 2 spots. So I get 14 points, and I'm just going to say since this is bigger than 5, that's going to tell me to round this up. 14.3% for the discount. Number 13, Claire estimates that her brother is 4 feet tall. When they get measured at the doctor's office, her brother's height is 4 feet 2 inches. Should Claire's or the doctor's measurement be considered the actual height? And explain. Well, definitely the doctor's measurement should be the actual height. He's probably pretty precise. And remember, it said Claire had an estimate. So that's not the actual, that's just trying to get close. Okay, so definitely the doctor's. Number 2 says, what was the error expressed in inches? Well, he's actually 4 feet 2 inches, 4 feet 2 inches, and she estimated him to be 4 feet. So what's the difference there? Well, it's just those 2 inches is the error. Number 3 then says, what was the error expressed as a percentage of the actual height? Okay, so if I took the error, which I know was 2 inches, and I'm trying to find that percentage of the actual. So remember, of often tells us that that's the whole, okay? So I'm going to put that in my denominator, and the actual height was 4 feet 2 inches, but if I note, this is in inches, I need to also put 4 feet 2 inches in entire inches. So 4 feet in inches would be 48 because there's 12 inches in 1 foot. So 12 times 4 would give me 48. And then if I add those 2 inches on top of that, his actual height is 50 inches. So what was the error as a percentage? Well, I'd have to take 2 and divide it by 50. And when I do that, I would come up with 0.04, and when I move that 2 spots to the right, that gives me, 4%. 2 spots to the right is 4%. So her estimate was 4% off, which isn't too bad. That's pretty good for an estimate, I'd say. Number 14 reads, to be labeled as a jumbo egg, the egg is supposed to weigh 2.5 ounces. Priya buys a carton of jumbo eggs and measures one of the eggs as 2.4 ounces. What's the percent error? So the first thing is to find the measurement error. How many ounces is this egg off of what it should be? Well, 2.5 minus 2.4, that's just a tenth of an ounce, or 0.1 ounces. Okay, that's the first step, is you need to find how much is it off from the actual. And then to find that percent error, we just need to divide it by what it should be. It should be 2.5 ounces. Okay, so when I take 0.1 and I divide that by 2.5, I come up with 0.04. Same as the last one, 2 spots to the right, gives me that 4% for an error. And lastly, finishing off with number 15, it says, a fisherman weighs an ahi tuna, which is a really big tuna, on a scale and gets a reading of 135 pounds. If you've never had ahi tuna, oh my gosh, it is delicious. You gotta try it sometime. The reading on the scale may have an error of up to 5%. What are two possible values for the actual weight of the fish? Okay, so there could be an error of up to 5%. Well, so the first thing we need to do is figure out what is 5% of 135. Okay, so if I did that, I'd do 0.05 times 135, and I'd come up with 6.75. And if you think about it, this should be in pounds. Okay, so that means that scale could give us an error that's 6.75 pounds too much or too little. Okay, so that means I need to add 6.75 to 135, and I need to subtract it from 135. And that'll give me that range of what the actual weight could be, just because that scale can have a 5% error. So 135 minus 6.75 would give me 128.25. And 135 plus 6.75 would give me 141.75. So this range means I could have any answer between here and it'd be up to 5% error. So I could have anything, like it said two possible values, so it could be something like 130 pounds, or it could be something like 140 pounds. These two are in between this range of numbers. Okay. All right, that finishes up the review. Those are 15 problems that are going to be very similar to what you might see on the test. Please let me know if you have any questions on any of them, and thanks for watching.